much for joining us today. I'm excited to share how Google Cloud can help you reduce your Web3 infrastructure costs and operations. And just a quick intro before we get started. I'm Nalin Mittal, and I lead Web3 products for Google Cloud. I'm based in the Bay Area and have been with Google since 2016, initially working on Firebase and Hotel Search. For the last several years, I've been building distributed applications on the blockchain, mostly with Solidity on Ethereum. I'm really excited to share what Google Cloud is doing with Web3. For today's session, we'll start with a really quick overview of Web3 technology, specifically the growth we're seeing as well as some of the challenges. Then we'll share how Google Cloud is participating in the ecosystem and what we've done so far. Finally, we'll show you how you can use Google Cloud today to query blockchain data regardless of how much experience you have with this technology. All right, let's get started with a high-level overview. So Web3 is broadly defined as the third generation of the web that offers users ownership and transparency through decentralized and permissionless infrastructure. We're seeing Web3 enable new kinds of decentralized financial applications, change how communities are governed and organized through decentralized autonomous organizations called DAOs, and revolutionize content ownership and monetization, which has implications not only for artists and content creators through NFTs, but also game developers and gamers. Over the last few years, we've seen tremendous growth in the development and adoption of Web3 technologies, and we wanted to share these data points with you. We now have over 80 Web3 companies valued at over $1 billion. Cryptocurrencies have a total market cap of nearly $1 trillion. And while we're seeing the decentralized web grow, we're still seeing 32% of blockchain nodes hosted by a single cloud provider. One stat that I found really interesting is that 4.2% of the global population now owns crypto assets. And finally, we're seeing web developers rapidly adopt Web3, with 65% of the Web3 developer population joining in 2021. This is tremendous growth, but it's important to note the new challenges that come along with Web3. With respect to regulatory compliance, there's no playbook for how large publicly traded companies get involved with Web3. And there's still many areas on the policy side of things that are unsettled. We're seeing heightened security posture because due to the pace of innovation, we've seen an increased number of security vulnerabilities. Nearly $2 billion of crypto assets have been lost to various exploits over the last year alone. It's also not always clear to developers what data should be stored on-chain versus off-chain. Depending on the network and its congestion, it can be very expensive to store data on the blockchain and potentially cost prohibitive for some business models. And this new blockchain ecosystem requires an entirely new developer toolchain. For example, the Ethereum ecosystem, you have different tools like Hardhat or Truffle to deploy, upgrade, and interact with smart contracts. And because smart contracts are immutable, developers are forced to learn an entirely new way to maintain and evolve their applications. You also have block explorers like Etherscan, which make it easier to view on-chain data. And lastly, it's increasingly difficult to find skilled developers that understand and stay on top of these technologies. So what's Google Cloud doing here, and what's our view of Web3? Well, let's take a step back and look at Google's mission. It's to organize the world's information and make it universally accessible and useful. And Google Cloud's mission is to help organizations digitally transform their business. This means helping them with many of the challenges we just talked about. We help customers move from on-premise servers to the cloud, and now we want to help organizations embrace and adopt Web3. In fact, our goal is to be the preferred platform for Web3 development. This is an ambitious goal and one we don't take lightly. We're focusing our efforts on democratizing blockchain data, simplifying management of blockchain infrastructure, and helping the developer ecosystem build Web3 skills and community. We're firmly committed to being the best place for Web3 developers to build. So let's talk about what we've done thus far. Solana is one of the leading layer 1 protocols, and we help them use Bigtable to store all historical transaction data and make it accessible to developers so that it's globally available and fast to query. Dapper Labs is one of the leaders in the space and created the ERC 721 standard for NFTs. They built the first blockchain app to reach 1 million users, NBA Top Shot, and they deployed nodes on GCP to achieve the performance required by their users. BlockDaemon gives their customers access to a variety of blockchain networks through node and API solutions. And Nansen rapidly grew their user base through real-time data and a predictive AI model. So over the last few years, we've been working hand in hand with crypto native companies to meet their goals. And one of the offerings available publicly to everyone today is our BigQuery datasets. So let's take a minute to look at those and see why they're important. It's really hard to find simple questions like, what is the total value of all Ethereum transactions over the last 2 weeks? Or which NFT does a particular wallet address hold? To be able to execute these kinds of queries, you need to index every single block from Genesis. This means getting access to a node, either operating your own or finding a third-party provider. Then you use the API for that node to query and index all historical data. Then listening for new blocks and transactions as they're finalized. And of course, you need DevOps to ensure that these processes are operational and healthy. So as you can see, it's a pretty involved process. The good news is this data is already available to you today without the need to do any of the steps we just talked about. Our BigQuery public datasets have support for 9 different chains, including Ethereum, Bitcoin, Polygon, Dogecoin, and others. We worked with the open source community and our friends at Nansen to develop an open source ETL repository to index the data. And you only pay for what you use through BigQuery standard pricing. Okay, so enough talking. Let's get hands-on with the product and show you how you can query blockchain data with little to no experience. All right. To access the BigQuery datasets, you'll first need to create a Google Cloud account at cloud.google.com. Once you've done that, navigate to the Cloud Marketplace. Use the hamburger button in the upper left to reveal the navigation menu, and then click Marketplace. Once you're there, we'll search for the Ethereum dataset. Select Ethereum cryptocurrency, and then click View Dataset. We'll want to search for this in the Explorer and pin it for future reference. You'll want to choose the crypto_Ethereum, not the classic. Okay, let's review the tables that we have available to us. We won't go over all of them, but let's review the most relevant ones for today's discussion. We have balances, which contains the Ethereum balance for each wallet address. We have blocks. So the Ethereum blockchain is comprised of a sequence of blocks, and as each block is finalized, it's written to the chain. So this table gives you information about each one of those blocks, including the time when it was finalized, the block number, the gas used, the transaction count, and other metadata. There's also a transactions table, which contains each and every transaction that occurred on the Ethereum blockchain, including the to address and from address, the value of the transaction, and the block it belongs to. There's a lot of other metadata here that we won't go into. 2 other tables we have available to us are contracts. This contains information about smart contracts on the Ethereum blockchain, including the address of that smart contract, the bytecode, and the block it belongs to. And then finally, we have tokens. This contains information about other tokens, also known as ERC20 tokens on the chain. And you'll see the address of those tokens, the symbol, the name, and other information. Okay, so let's take a look at how we can query these tables to understand what's happening on the blockchain. The first thing we'll do is look for the latest block number we have. This will tell us how fresh the data is in our data set. We'll actually look at the range of blocks available to us, so we'll query for the lowest block number and the highest block number. To do that, we go up here and click Query, in New tab, and we can formulate our query. You'll notice that the right table, the blocks table, is already set for us. We can get rid of the where and limit clauses. Now for the selection, we'll select the min number and the max number. And we'll run this. Now the min number will show us the oldest block available to us, and the max number will show us the most recent block available to us. Okay, so the min number is 0, which makes sense. That's the first one. And the max number is this one that ends in 3076. So let's go to etherscan.io, which is an Ethereum block explorer. It shows you all of the blocks that have been written. So if we look at 3076, it's down here, and we'll see that this was written 4 minutes ago. That means the data available to us in the data set is about 4 minutes old. Great. Now let's take a look at the balances table. The balances table has wallet addresses and the corresponding Ethereum balance for that wallet address. So let's do a query now where we can look for maybe the top 10 wallets by Ethereum balance. So we'll do a new tab, and this time we'll select star from this table where, actually let's do an order by Ethereum balance descending, and we'll look for the top 10. So this will give us the top 10 wallet addresses by Ethereum balance. So if we run that, great. And we'll see we have wallet addresses and the corresponding balance. And keep in mind that these balances are not in ETH, but rather in WEI. So they have to be converted to ETH. But you can see how many WEI each address has. And these are the top 10 biggest accounts. Okay, let's do one last query, and let's look at the most popular tokens by transaction volume. So we have this tokens table here, which has information about each token as well as the address for that token. And we have this transactions table. So what we can do is we can create a new query. And to save some time, I'm going to paste in a query that I've already written, and I'll walk you through this. So what we're doing here is we're selecting the token address and the token name from the tokens table, and we're joining the tokens table with the transactions table. We're also looking at transactions that happened within the last 30 days. And we're grouping by the token address and name. So what this is really doing is looking at, within the last 30 days, which tokens had the most transactions associated with them. So let's run this. And here you go. You'll see that Tether is by far the most popular token with 2 million transactions, followed by Wrapped Ether, Shiba Inu, and a bunch of others here. So we were able to see which ones are most popular. And of course, you can change the interval that you want to look at. If you wanted to look at, maybe the top 25 over the last 60 days, we can run that as well. And it's a larger data set, so it might take a little bit longer. But here you go. We can see largely it's a similar top 3, but then there's some movement below that. So with that overview, hopefully you have enough information to do some exploration on your own of these data sets. Keep in mind that as you do that, each table has the schema available to you, details about what this table is, how many rows and what space it takes, as well as a preview of the actual data. So you can click in there and explore the data without even writing any queries. And as a reminder, we looked at the crypto Ethereum data set, but there's several other crypto related data sets for Bitcoin, Bitcoin Cash, and a host of others. So all of these have their own schema, but you can query them via SQL as we did the Ethereum data set. Okay, so that's how easy it is to query blockchain data through BigQuery. You also learned a little bit about what Google Cloud is doing more broadly with Web3. Thank you so much for taking this time with us, and I hope you enjoy the rest of Next 22.